Let us do some questions first of all. Draw Lewis dot structure. Of H2O and NO3 negative. NO3 negative and one more we will draw. O3. Okay. So at least draw H2O and NO3, and then we will look at O3, ozone. Send your answers on my WhatsApp. Okay. I will give you guys 4 minutes for this. You just have to give me H2O and NO3 negative. Okay, Yasir, let Abdullah take photo and send your answer also. Okay, fine, Yasir. Okay. Harsha, send me whatever you have done. Mart is not connected to audio. Harsha, please send me whatever you have done.
Yes, sir.
Hmm.
So those dots next to H were by mistake.
Sorry.
So those dots next to H was by mistake.
Okay, that's fine. But is the nitrogen happy? Also, one more mistake you are doing, Harsha, is that you are not taking into consideration this negative charge. Why is that? Harsha? Negative, that means we have to add one more electron, right? So first of all, let us see first one, H2O. H2O is going to have how many valence electron? Total valence electron in H2O will be equal to 2 for hydrogens plus 6 for oxygen. That will be equal to 8. Then out of hydrogen and oxygen, hydrogen cannot be a central atom. That is why oxygen will be central atom. So skeleton will be looking something like this. Right? Now, since hydrogen, it already has 2 electrons. I don't have to add any electron on hydrogen because hydrogen are happy. Hydrogen just need 2 electrons. Then I have used how many electrons? 4 electrons. 4 electrons are remaining. So 1, 2, 3, 4. So the dot structure would be something like this. Oxygen. Will be something like this. Okay. Now this is for H2O. Let us see for NO3 negative. Yesterday also, Harsha, you did not count the negative charge here. Okay, just take care of this. NO3 negative. So total valence electron will be equal to how much? Total valence electron will be equal to nitrogen has how many valence electron? 5 plus 6 into 3 will be 18 plus one more. So 8 plus 6 will be equal to how much? 18 plus 6 will be equal to 24. Then I have nitrogen, which is less electronegative, and then I will draw 3 oxygens like this. Now I have used how many electrons? 1, 2, 3, 4, 5, 6 electrons. So 24 minus 6 will be equal to how much? 18. So 18 electrons are remaining. So I will put up the 18 electrons like this. 1, 2, 3, 4, 5, 6. So this oxygen is happy. So I move to the next oxygen. 1, 2, 3, 4, 5, 6. And 6 is remaining. So 1, 2, 3, 4, 5, 6. I go to the next atom only after the first atom is happy. Now, if I look at all the oxygens, so oxygen has 6 plus 2 electrons that is bonded. That will be equal to 8. All of the oxygens are happy. But here the nitrogen is not happy because nitrogen is only having 1, 2, 3, 4, 5, and 6 electrons. So it will ask one of the oxygens to give me some electrons. So what will one of the oxygen do? They will give the electrons to nitrogen. And what will happen? You will get oxygen with a double bond with nitrogen, a single bond with oxygen like this, and a single bond with oxygen like this. Now this oxygen will have only 2 lone pairs left. This will have the 3 lone pair as it is, and then it will be.
So we can't add 2 extra electrons to nitrogen.
Extra electrons. Where will you get the extra electrons? Tell me. You have only 18 electrons, right? Yes, Harsha.
Yes. Okay.
Got it?
Yes.
No. Please write this down. Then we'll look at the structure of ozone. Anyone still writing? Please let me know. Is anyone still writing? Just a second. That's it was taught in yesterday's class, total valence electron. Anyone still writing? Please let me know. Anyone still writing? See, I've asked 3 times. No one is writing. Okay.
Yeah, done.
Sorry? Done?
Done. Completed.
Third structure is ozone. O3. Now for here, the total valence electron will be equal to how much? 3 into number of valence electron in oxygen is equal to 6. So 6 is 18. Then we have to put up the skeleton. So skeleton will have, now here we have 3 oxygen atoms. So one of the oxygen will be in the middle, the other 2 oxygen will be on the sides like this. Okay. Now we have to have how many electrons? 1, 2, 2 bonds. That means 4 electrons. So how many electrons are remaining? 14 electrons are remaining. So I will put up the 14 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Okay. So from here we can easily see that the side oxygen atoms are completely happy. They are having 8 electrons, but the middle oxygen atom, it is having 1, 2, 3, 4 from the bonded and 5, 6 from the bonded electrons. So here they are having only 6 electrons. So what it will do, it will ask one of the oxygen atoms to give it electrons, and what will happen? We can draw the structure like this now. When it gives a pair of electron, this will become double bond, oxygen, single bond, oxygen. Now this oxygen, since it has given, it had 3 pairs of electrons, that is lone pair. Now it will have only 2 pairs because it gave 1 pair for bonding. This will have 2 lone pair electrons, this will have 3 lone pair electrons. That's it. Now all the oxygen atoms, you can see that they are having 8 electrons. Please write this down once you're done. Write the next topic, formal charge. Now, the determination of formal charge on each of the atom, that is very important. And it's not very tough, it's very easy. So formal charge is determined for each atom. formal charge is determined for each atom. Okay. Now, what is the formula of formal charge? Formal charge is equal to the total number of valence electron minus number of non-bonding electrons. Number of, ऐसे लिख लीजिए, थोड़ा सा बड़ा हो जाएगा. Number of non-bonding, sorry, number of non-bonding electrons. Then you have to minus half of the number of bonding electrons. Half of number of bonding electrons. Okay. Now, what is non-bonding electrons? You can directly write the total number of valence electron total number of valence electrons, minus the lone pair electrons, not the number of pairs, but rather lone pair electrons. Okay. Lone pair electrons minus number of bonding electrons. In one bond, we have how much? In one bond, we have 2 electrons. So we have to count 2 electrons and then divide by 2. So what we can directly write? We can directly write number of bonds. Okay. Number of bonds. So formal charge, very easy formula. Total valence electron minus lone pair and minus bonds. This total valence electron of atom. All of these things will be for an atom. Okay. Right, of an atom. Write this down, then we'll see how to calculate the formal charge for each atom. Anyone still writing? Please let me know. Anyone still writing? Please let me know. No one is writing. Here, first of all, we will take an example of O3. The formal charge is only formal charge. You can calculate the formal charge on each atom only after you have drawn the Lewis dot structure. So we saw the Lewis dot structure of ozone was oxygen with double bond oxygen and a single bond oxygen. This oxygen, it had 2 lone pair electrons. This had 1 lone pair electron. This had 3 lone pair electrons, right? Now here we have 3 oxygen atoms, 1, 2, and 3. So we'll calculate we are going to calculate the formal charge on each. So when I calculate the formal charge on the first oxygen atom, so for oxygen atom, the total valence electron will be always equal to how much? 6. Because for oxygen atom, total valence electron is equal to 6. Now, how many lone pair electron it has? It has 1, 2, 3, 4 lone pair electrons. So 6 minus 4. How many bonds it has? It has, you can see that it is having only 2 bonds. So you will write minus 2. This will be equal to what? 6 minus 4 minus 2 will be equal to 0. So this first oxygen atom will have 0 formal charge. Second, if you are going to look at the second oxygen atom, then the formal charge will be equal to, again, total valence electron is 6 minus the number of lone pair electrons. Okay, so how many electrons is present? 1 and 2. 6 minus 2, and how many bonds? 1, 2, and 3 bonds. What I will do minus 3. From here you can see 6 minus 3 minus 2 will be equal to minus 5. This will be equal to what? Plus 1. We have got the value of plus 1 here. Okay. So this second oxygen atom, it is having a formal charge of plus 1. Let us look at the third oxygen atom. Formal charge will be equal to, again, oxygen has minus number of lone pair 1, 2, 3, 4, 5, 6 minus number of bond is equal to 1. So this will be equal to 6 minus 6 is equal to 0 minus 1. So formal charge will be equal to minus 1. All of you understood this? Yes or no? Please tell me. Abdullah,
Yes, sir.
Martin, Yasir, and Harsha. Harsha, समझ में आया?
Yes, sir.
Please write this down. Then we will look at a few more examples. Harsha and Martin done? Please let me know if you're writing. Please let me know if you're writing. And then you have to calculate the formal charge on each atom of NO3. Calculate. Achha, wait a second, guys. When we draw the structure, na, NO3, so you have to draw a square bracket, put up a negative charge here, okay? So can you please edit this? Please write it once again, NO3 negative. And it has charge, so you will draw square brackets and then a negative charge there, okay? Calculate formal charge. On each atom of NO3 negative.
So for nitrogen, should we calculate the total valence electrons as 5 or 6?
No, just think about the nitrogen atom in the periodic table. Don't have to look at the structure and think, okay? So how many valence electron does nitrogen have?
That's 5.
5, no? So you'll take 5 only.
So, but the charge, we don't have to add that.
No, charge we don't have, no? I mean, you don't have to worry about the charge here. There was no, I mean, nothing for charges here, no? Charge is taken care when you are drawing the Lewis dot structure, okay? So once you have drawn the Lewis dot structure, from there you can calculate it very easily. Ajay, can you please send it on my WhatsApp?
Okay, sir.
Nitrogen 5 minus 0 plus 1. Okay, very good. First oxygen, it will be having 6 minus 4. First oxygen is this one. 6 minus 4 minus 2. 6 minus 4. Then we have second oxygen atom. This one, third one, this one. Yeah. What about you, Martin?
Yes, sir.
Yes. Did you do it?
And the
Okay. Send it quickly. Martin, send me whatever you have done. Send it quickly.
Okay.
Whatever you have done. Martin, can you please send me whatever you have done?
Yeah, I want some bonus.
You have calculated this for what? Yes, Martin.
Yes, sir.
Just a second. What you have calculated? I mean, which atom?
Nitrogen.
You have to show that, no? That you are writing for nitrogen. Yeah, guys, we have just seen the structure of NO3. Nitrogen doubly bonded with oxygen, single bond with oxygen, another single bond with oxygen. These two options they have 1, 2, 3, 4, 5, 6. This also have 1, 2, 3, 4, 5, 6. This has 1, 2, 3, 4. Only 4, and those 4s are like this. Now, if I talk about nitrogen, for nitrogen, I can say the formal charge will be equal to total valence electron is 5 minus number of lone pair is 0 minus number of bond pair is equal to 1, 2, 3, 4. So this will be equal to plus 1. Now we have oxygen 1, 2, and 3. So for the first oxygen atom, I can say that formal charge will be equal to, for first we have valence electron is 6. Number of lone pairs 1, 2, 3, 4. 4 electrons which are non-bonded. The number of bonds is 1 and 2. So minus 2, which will be equal to 0. For the second oxygen atom, I can talk formal charge will be equal to, again, total valence electron is 6 minus number of lone pairs, lone pair electron 1, 2, 3, 4, 5, 6. 6 and bond is 1. So this will be equal to 6 minus 6 is 0 minus 1. For third, formal charge will be equal to 6 minus 6 minus 1. Again, same, that will be equal to minus 1. Okay, and that is why, as you can see here, we have plus 1 charge, here we have 2 minus. So plus 1 and minus 1 will balance each other and it will be left with minus 1 charge. So that's why NO3, it has minus 1 charge. Write this down, let me know once you're done. You guys will be having problem if you don't know what is the total valence electron. Okay, if you don't know what is the valence electron on each atom, nitrogen, oxygen, simple atoms, then you will be having problem for sure. And how to determine valence electron, how to determine valency, all of these things we have done in periodic properties. Martin, are you still writing?
Done.
Done. Right, next. Limitations of Lewis dot structure. First of all, number one. Oh, wait a second. Not limitation of Lewis dot structure. Rather, I should write limitation of Lewis octet rule. Okay, number one. Not applicable on is right, not applicable on for hydrogen atom as it can accommodate only 2 electrons. Second, does not explain stability of electron deficient compounds. For example, lithium chloride. Okay, LiCl. So in LiCl, what happens? Li has positive and Cl has 1, 2, 3, 4, 5, 6, 7, 8 valence electron. Lithium has 0 valence electron. Okay. So as you can see in this structure, if I lithium chloride structure, then you can see that lithium is only having how many? 2 electrons. So obviously it is not stable. Right. Again, you can write example LiCl. And then we have BeH2. Structure is like this. Beryllium bonded with 2 hydrogens like this. Because there will be only 4 valence electron. Beryllium ka 2, hydrogen ke 2, 4 valence electron, and we have made skeleton out of that. So here beryllium is also not having 8 electrons, hydrogen is also not having 8 electrons, right? These are only 4 electron structure. So how is this stable? Then similarly you have BeF2, right? Similarly you have BF3, BCl3, BH3. All of these are examples of what? Electron deficient compounds. Now right next, third is does not explain stability of electron rich compounds. For example, what are electron rich compounds? वो हम आपको बता देते हैं. You can write molecules that have more than 8 electron in their valence shell. It's called, or rather are called, electron rich compounds. Okay, so examples are many. Some examples you can write PF3, phosphorus pentafluoride. Okay, 1, 2, 3, 4. And this phosphorus is having, central atom is having how many electrons? 10 electrons, because it is having how many bonds? 4 bonds, sorry, 5 bonds. SF6, sulfur hexafluoride. Here it is having how many electrons? 12 electrons. Okay, similarly, IF7, I am being bonded with 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 3, 3, 6. Okay. So this is having 14 electrons. Okay, so all of these are what? Examples of electron rich compounds, and these compounds exist. But at the time of Lewis, most of the compounds that Lewis had, all of them were satisfying the 8 electron rule. So that is why Lewis gave the octet rule. Otherwise, when slowly more and more compounds were found out, we saw that Lewis octet rule is not applicable for all of the compounds. So that is the limitations. There is one more limitation, please write. इसमें एक और चीज लिख लीजिएगा. These are also known as hypervalent compounds. So they have valency that is hyper. Valency generally 8 तक रहने से सही रहता है. Above that it is hypervalent. Okay. So these are also known as hypervalent electrons. Anyway, this is the third one. So fourth does not explain stability of odd electron species. What are odd electron species? For example, nitrogen dioxide. So in this case, you will see nitrogen has how many? Total valence electron will be equal to how much? Nitrogen के पास 5 plus 2 into 6, which will be equal to 12 plus 5, right? 5 plus 12, which will be equal to 17. Okay, now the structure of NO2 is something like this. Two bonds here, two pairs here, and it has a double bond like this. And then one electron, that is odd electron on nitrogen atom. A similar example is for NO also. Okay, so when you see these compounds, you will say that these are not odd electron species, and it is not explained by the Lewis octet rule how these compounds are being formed, but they exist in the nature. Write this down, let me know once you're done. NO2, NO, these are examples of odd electron species. All of you done?
Yes, sir.
That's it for the limitations. Now starts important theory. That is bonding theories. So you have to study two bonding theories. Okay, so this is very important. Bonding theory is very important. There are two theories that you have to learn in this class. First one is known as valence bond theory. The other one is known as molecular orbital theory. So we call this प्यार से VBT और इसको प्यार से हम बोलते हैं NOT. Okay, so first of all, we'll understand valence bond theory. Then we will look at the molecular orbital theory. So write the heading valence bond theory. So valence bond theory is very simple. It's very simple. It says that, see, each and every atom, it has orbitals. And in these orbitals, there are electrons. In these and these orbitals, when they overlap, haath hai, you can understand the orbitals as hands for atom. And when they hold hands, that means when they overlap each other, a bond is formed. And bond mein kitne honge? There will be two electrons. So this is just what? AB. So the basic idea of valence bond theory is what? Bond, rather covalent bond is formed by overlapping of two half-filled atomic orbitals of their valence shell. Okay, please write here. Basically हम लोग क्या हो रहा है यहाँ पे? Overlapping of orbitals. Overlapping what does VBT say? Please write. Covalent bond is formed by overlapping of two half-filled atomic orbitals of their valence shell. Of their valence shell. Okay. Now, right, next point. This is just initial part of what the valence bond theory. It says covalent bond, how it is formed by the overlapping of two half-filled atomic orbitals of their valence shell. Valence shell के atomic orbitals के half-filled means the orbitals should be having only one electron each, and when they overlap, they form covalent bond. Obviously, if there is a good overlap between the orbitals, then a strong bond is formed. Please write greater the extent of overlapping between two atomic orbitals. Stronger is the bond formation. Stronger bond is formed. So how there should be effective overlapping or good overlapping? Please write. Next point. For effective overlapping, there must be proper orientation. There must be proper orientation between two atomic orbitals. Okay. Now, please write this down. So we have all seen orbitals, right? Mainly we'll see p orbitals and s orbitals. So you have seen the p orbitals, right? So p orbitals, they have plus phase and minus phase. So these orbitals are nothing but a kind of wave. And wave also, if it is above the axis, it is having plus phase and this is minus phase. Okay. So plus and minus are not charges. These are just these are phases of a particular wave. These are phases of a particular wave. Okay. So first of all, understand this, that there will be positive and negative phases. Okay. Now, after this, you will write types of overlapping. इसको लिखने की जरूरत नहीं है, बट हमने बस बता दिया यहाँ पे. I just told you this. Types of overlapping. Now, there are there are three types of overlapping. एक को कहा जाता है positive overlapping. The other one is known as zero overlapping, and then we have negative overlapping. Positive, negative, and zero. Okay, so you have positive overlap, negative overlap, and zero overlap. Very simple definitions, very simple. Please write number one, positive overlapping. Please write overlapping of atomic orbital with same sign of psi. Psi is the amplitude, है ना? Psi we have seen in atomic structure. It is what? It is amplitude. So when amplitude they have same sign, then there will be what? Positive overlapping. And please write, this results in attractive forces. क्या होता है इससे? Attractive forces. Examples कैसे आ सकते हैं? देखिए, I have a s orbital, spherical in shape, with positive sign. Again, s orbital with a positive sign. Both of these are going to overlap and they will form something like this. right? Both of them are having what? Positive sign only. Okay. Similarly, if I have, this is known as SS overlap. Secondly, you can have both of them negative. Then also it is not a problem. Then also it is not a problem. There will be positive overlap. That means the electrons will be filled here and there will be attractive forces. Okay. This is a good positive overlap. There's a positive overlap. Similar overlap will be seen if the negative is also negative and negative phase are also combining overlapping because it is same phase. You just need to have same phase. Positive and negative, it does not matter. You should have same phase. Similarly, if you have S and P, S orbital having positive, positive and negative. So see, the orientation is also important. So positive is coming from this side, positive is coming from this side. Okay. And then only they can overlap. This is such a, okay. So here we have what? Positive है. यहाँ भी positive है, इधर भी positive है, and यहाँ पे क्या था? Negative. So here we are having good overlap. Okay, positive overlap. You can also have PP overlapping. How will PP overlapping look like? You have P orbital like this. We rotate this down first of all, rotate horizontal, and then copy it again. Okay, so again, negative, positive, positive, negative. So positive are overlapping. So what will happen? So this will be positive overlap, right? This will be positive overlap. So good overlap, there will be electron density between these two signs here. There will be electron density. Okay. Similarly, what you can have, both of these can be negative also. Okay. Again, good overlapping, positive overlapping. ठीक है, सबको समझ में आ गया? When it will be positive, yes or no, please tell me.
Yes, sir.
Similarly, please see one more case. When we have two, just a second. If you have something like this, okay, you have something like this, and these are, so what we can do here also, there can be overlap. So positive and positive, negative and negative. So this is also what? This is also a positive overlap. Okay, overlap which results in what? Which results in attractive forces. Please write this down. Let me know once you're done.
Okay.
Right, next. Negative overlap. Second.
So we won't go for D subshell.
Sorry.
So it won't be there for D subshell.
D, there can be for D, but we don't generally do D because we mainly have P block elements. D and F you are going to look at in the next class. Okay, first standard.
Okay.
You can draw it for D also. Okay, so right next for negative overlap. So in negative overlap, please write overlapping between atomic orbitals with different sign of psi. Overlapping between atomic orbitals with this results in repulsive forces. Okay, so you can take all the previous cases जो हम लोगों ने लिया था यहाँ से. So here we are having same phase, same sign of psi, same amplitude. All of them are positive or negative, right? But यहाँ पे आपने change कर दिया. So what is going to happen? The positive and negative when they come and overlap with each other. तो मान लीजिए हमने इन्हीं दोनों को बिल्कुल copy paste कर दिया. Okay. So when both of these they come with each other, positive and negative, they will cancel out each other. क्या करेंगे ये सब? Cancel कर देंगे. Cancel I can show like this. So there is vacant space here. Okay, both of them have cancelled each other. Similarly, if you have positive negative में तो एक ही केस बनेगा इस तरह से है ना, positive negative ही रहेगा. Opposite signs. So if you have S and P, in that case also what we can do? Let us suppose this was negative and that is positive. Now when they will combine with each other, so there again will be cancellation. ठीक है, फिर से क्या हो जाएंगे, दोनों एक दूसरे से कैंसिल हो जाएंगे. Similarly, you can have positive negative like this. So when they overlap with each other, so again there will be what? So there will be vacant space here. Okay, there is repulsive forces. They will cancel out each other. You cannot, this option we have already taken. When you have positive negative like this, and again cancellation. So all of these are going to result in what? All of these are going to result in repulsive forces. Please write this down quickly. Is everyone done? Yes or no? Please tell me.
Yes, sir.
Right, next, zero overlap. Right. Zero overlap में you will have same and opposite phase simultaneously. Overlapping between atomic orbitals with same and opposite sign of psi simultaneously, है ना? अब बोलिएगा सर ऐसा कैसे होगा? ऐसा हो सकता है. Let us suppose we have p orbital like this, है ना? अच्छे से बनाते हैं p orbital. Wait a second. थोड़ा और अच्छे से बनाते हैं. ये थोड़ा बहुत ठीक से बन गया. इसको कर देंगे रोटेट. So we have got p orbital like this. ठीक है. Now this p orbital will have positive sign, positive amplitude here, negative amplitude here. And if I take a s orbital, so s orbital या तो positive होगा या तो negative होगा. अब ये देखिए आप. Now what is happening? Can all of you see? It is overlapping with positive and negative sign simultaneously. Yes or no? Please tell me.
Yes, sir.
Right? So this is an example of what? Zero overlap. This is an example of zero overlap. Okay, और examples आप देख लीजिए. So you can see if you have positive, negative, positive, negative, and if both of these are overlapping, so here also you will have similar scenario, right? There will be overlapping between, simultaneously overlapping between positive and negative phases, right? Positive and negative sign of psi. Okay, so यहाँ please लीजिएगा. This also results in repulsive forces.
Sir, it's not possible for S and S, right?
No, for S and S it will be either zero or it will be positive. Sorry, it will either be negative overlapping or positive overlapping. Okay, so in the next class we will look at different types. See, only positive overlapping, you will write a note here. Only positive overlapping results in bond formation. Okay, only positive overlapping results in bond formation, and we are going to look at different types of bonds formed depending on how the different atomic orbitals they overlap with each other. Okay, so that will depend on the orientation. So we are going to look at them in the next class. Is everyone done?
Yes.
Okay. Tell me one thing. Can you look at your app and the Learnivio website? Is a new test activated?